Hello everybody and welcome back to the physics engine tutorial. In this episode I'm going to show you how we can do a collision detection between polygon and circles. Again, this will be just the theory behind it, and in the next episode I'm going to implement that too. Alright, let's jump right into that. Okay, so we have two methods we're going to call. Well, actually, it's a bit easier than the polygon versus polygon, in my opinion. And we have again one main method we're going to call, that's the circle versus polygon. And then in this method, we're calling circle versus polygon edges and circle versus polygon corners. These are two cases we need to check. But luckily this time we won't have more nested methods. Okay, so I'm gonna show you what I mean with these two cases. So the first case, let's say, is the circle versus vertice or the polygon corner, like this one, right? And you can see there are dotted lines, and that means there are areas, like places where we need to check for the corners of a polygon or the edges. In this case, we need to check the circle against the vertice of the polygon. Yeah. Note also that these dotted lines are perpendicular to the edge here. And this limit here is right at the end or lies on the vertice, and it's just perpendicular to the edge here. So these are the areas we need to do, and the other one, the other check, and this is the area where we need to check against the corner of the polygon. This is the circle versus edge case. Here we check the circle versus the edge. And we have to do this if the circle lies in between these two lines. Okay, and yeah, I'm going to show you how we can calculate that. That should be well, I hope it's easy to understand. Okay, so as I said, we have two methods: circle versus polygon edges and circle versus polygon corners. You can see the areas again where we gonna call these methods, and here it's again a short visualization. This area we call the circle versus polygon edges, also in this one, also in this one, and at the edge cases we're gonna call the other ones, the other method. Note that we are not gonna call 3 times this method. We are doing this case here in one method, also in this, also the circle versus polygon corners, we're gonna do that in one method. So, well, the method is gonna call circle versus polygon corners. So we're not gonna call these ones 3 times like displayed here. I just want to show you in which areas we need to call which method, okay? All right. So then let's jump to the circle versus edge case. Here you can see a polygon with two, well, with actually 3 vertices, but the vertices of interest are just these two. We have the vertex 0 at position 0 and the vertex at position 1. And these two vertices are defining our edge. Let's call it like this. Here we can see also these dotted lines, which just show you our area, which is valid for a collision. But you will see what I mean with that shortly after this one, after this slide. Okay, so how we can calculate these things for this case? We're going to use again the dot product. First, we are going to create a direction vector from the first, from the second vertice I mean, yeah, well, a direction vector from the first one to the second, and we can calculate this like this one. Just subtract the vertice at the first element minus the vertice at the with the element of 0. I mean the vertice with the first index, that's right, and with the vertice with the index of 0. I'm always confusing this. Sorry for this. Yeah, then we need to create a direction vector from the vertice to the circle center. So from this one to this one, we just subtract the circle position, that's the center of the circle, minus the vertice at this position. Then we are normalizing this direction vector. I mean the to next. We're gonna normalize it like I did it in here. And then we take the dot product with the vertice to circle. So we are making a dot product with this vector, with the normalized direction vector from this vertice to this vertice. And then we get the circle projection direction to next projection. Okay, and this is the projection value, basically. And with this one, we can see if the circle is in the right area or in a wrong area. But I'm going to show you this in the next slide. This is one case when the circle is not in the right area for a edge, for the circle versus edge case. And in this case, if we project this vector to this direction vector from vertice 1 to vertice 2, then this will be negative. The projecting depth will be negative. And this is one case where the value or the case is not valid anymore. And this is the other one. If the projection value is too large, if it's larger than the length between these two vertices, then it's also not going to be in the right area to do the edge check. And so we can define which case we need to do, basically. We're first doing the circle versus polygon edges case, check if the circle is in the near of an edge, and if it's not, then we just let the penetration and so on, just let it null, and then we're going to do the circle versus corner check, and then we have to find something. Yeah, and else it's going to be null again, because then there's no collision. But if there's no valid if there's no valid case, like the circle is not in this zone here, it's not here, it's not here, and it's not in this area, then we know the circle must be in the corner areas. And if there's still no collision, then we can say there is absolutely no collision with the polygon at all. Yeah. Okay, so let's see the first case again, a little bit in more detail. Here, we're gonna project this vector. We're gonna do a direction vector again from the vertice 0 to the circle center. And we have a direction vector that's I call it to next, from this vertice to the next vertice. Now we're gonna project this direction vector onto this direction vector. Note that this direction vector here, the orange one, is normalized. And if you project this one onto the normalized one, then we get a negative value. Yeah, this will be the negative value. Okay, then we have, yeah, and of course if it's a negative value, then it's not valid anymore. Then the second case, if the projection value is too large. So if the projection value is larger than the length between these two vertices, then we have the other case where this edge case where the, well, edge case where the polygon at the circle versus edge is not valid. So we need to jump then to the circle versus corner method. This is the second case where this one is not valid, and then we have the third case where it is valid, where the circle lies between these dotted lines in the right area. And if that's the case, we have to check for penetration. I'm going to show you this in the next one too, the next slides. So this here is valid if the value from the projection is greater than 0. That means this point here lies somewhere in this. I mean, you know, it's greater than well, 0. I mean, if this point here is above this dotted line here, right? And if the value is smaller than the direction vector from the vertices, then the point is somewhere in this direction, right? So it's between these two dotted lines. Then we can check for penetration. Okay, so as I said, we have two cases where a valid edge is found, like if there's no collision and then if there's a collision. Okay, there are two cases we need to check too. These are three cases where we need to check for where the circle is actually lying, in which area is the circle. Okay, and if the circle lies in the right area, like in this one, then we have to check again for two cases. And these are the cases for no collision and collision. And here we need to check if the circle is actually penetrating the polygon edge. Okay, and we can do this. This is an example for no collision. We again create a direction vector from the circle, from the vertex at position 0 to the circle center. Then we take the dot product again with this direction vector, with the green one, and take the dot product with the normal vector, which again is perpendicular to the polygon edge. Okay, so we take the dot product from this direction vector to the normal. And the value we get is this green, dark green line here. This is the projection. Okay, I didn't wrote it like here. But anyways, this is the value we get out of the, oh, I actually did. Here, it's the projection to edge normal. Okay, this is the value we get if we project this arrow to the normal. Then we get this value. And then at the final step, we need to subtract the circle radius from the projection value. Then we get the penetration depth. And this is the green line here, okay? This is the radius. We subtract the radius. We subtract the value from the projection with the radius. Then we get the penetration depth. And if the penetration depth is greater than 0, then there's no collision. As you can see, this line here, the circle, is not touching the polygon edge. Okay. And then, of course, there's the case where we have a collision. This is that's the exact same thing, but in this time, this circle is touching the polygon edge. And again, if the projection value from this arrow with the normal minus the radius, and yeah, if that's lower than 0, then there's a collision. So again, here's the arrow, the direction vector from the vertex 0 to the circle center. We project it with the normal. We get this green line here. This is the penetration, the projection to edge normal. Well, yeah, it's the value basically. And then if we subtract from this one the radius, okay, you can clearly see this is colliding with the edge. If we subtract this with this one, we can get here the penetration depth. And here you can see it's lower than 0. And if it's lower than 0, then there's a collision. And here we can also then create the data we need for the manifold to resolve the collision. We can do that pretty easily. The penetration depth is already seen here. We can calculate it like this. And the penetration normal is just the normal. It's just like this normal. Note that this normal can also be flipped or scaled by -1. It depends on your implementation. I need to check in my implementation if I scaled it with -1 or not. But we're going to see this in the next episode when I'm going to implement that. And then, of course, the penetration point. This is also pretty simple. Just add from the circle center. The circle center is here. Take the circle center, add the vector. Take the normal, scale it with the radius. Okay, then we have a vector which is like the radius. You know, it has the magnitude of the radius of the circle. But we need to flip it because this direction vector will still point in this upper direction like the normal. So we need to flip it again, and then we can add this direction vector here to the circle center, and then we get the penetration point, which lies exactly here at the end of the arrow. Okay, and this will be our penetration point. All right. Yeah, and then we have the circle versus vertex. That's everything we need. We don't need anything more. Yeah, and then we can jump to our circle versus vertex case. This is really, really simple. I think it's even more simpler than the circle versus circle collision detection, because here we just need one radius and 2 points. The points are, well, the corner of a polygon and the circle center. And here we're just going to compare two values. We're comparing the distance between these 2 points. Again, make a direction vector from this one to this one and compare the direction vector, the length of the direction vector with the radius. And if the distance is greater than the radius, then there's no collision. Then we have the case where there is a collision, and in this case the distance is just smaller than the radius. And that's it. How we can calculate the data for our manifold, it's also pretty easy. The penetration depth is just the vertex. Sorry, the penetration point is just the vertex. The penetration normal is the direction vector from the circle center to the vertex. We need to normalize it. Then we have the normal of the penetration. You can also multiply this by 1, but this arrow here is then flipped. Okay, it's then in the opposite direction, and we need to scale something with -1, probably the penetration depth, to make it work again then. Because then you see the weird behavior we had. I think it was with the circles or with the polygons. And then we have the penetration depth. Also pretty easy. Just take the radius of the whole circles. Yeah, the radius of the circle minus the direction vector from vertex 1 to to the circle center. Okay, so this direction vector, and then just subtract from the radius from here to here minus the direction, the length from the direction, and then you have this green line here, and this will be our penetration depth. And yeah, then we have everything we need for our physics engine to work with circles, with polygons, and yeah, we have pretty much every shape except concave shapes, but this is going to be a topic maybe in some bonus episodes at the very end of the tutorial. All right. Yeah, then let's see how it's implemented. See you soon. Bye.